settings to the highest one for better graphics. In this video we're going to talk about skeletal muscle, just an overview sort of thing. And so a skeletal muscle cell, as I mentioned in a previous introduction video, is cylindrical shaped and multinucleated. And a skeletal muscle cell is known as a muscle fiber. And interestingly enough, skeletal muscle cell, the fibers, are striated by a highly organized internal arrangement. So this muscle fiber has an internal arrangement. So if we pull pull some things out from this muscle fiber, we can find myofibrils. So muscle fiber contains many myofibrils. And if we take a portion of this myofibril, we can see that it's made out of some interesting structures known as the thin and thick filaments. So the myofibrils contain thick and thin filaments. The red is the thick and the blue is the thin filaments. But of course, the muscle fiber, the muscle cell, is actually part of a bigger organized structure. So if we look at this bone and a skeletal muscle which attaches on it, and we cut a cross section of skeletal muscle, we have the muscle, the organ. So this is what the muscle looks like as an organ. And the muscle contains, if we look at the cross-section, different portions of the muscles, and we'll look into this soon. But the muscle contains an outer connective tissue layer known as the epimysium. And I hope I pronounced that right. And so we take one of these portions of the muscle here. The portion of the muscle is known as a fascicle, and the fascicle also contains other internal structures. And the outer sort of connective membrane tissue is known as a perimysium. And then if we pull out one of these other internal structures of this fascicle, the portion of the muscle, this is where our muscle fiber is.
Just an illustration.
And the muscle fiber contains a connective tissue wrapping around it known as the endomysium.
Fibrous tissue.
And remember that a muscle fiber is the muscle cell. So this is this. And also the muscle fiber, the muscle cell, contains a membrane known as a sacrolemma. And again, if we remember, if we take one of the internal structures of the muscle fiber, we have a myofibril. And the myofibril contains the thin filaments and the thick filaments. So let's just recap. If we start off with a whole muscle, an organ, and we get a portion out of that, we get the muscle fascicle, which is a portion of the muscle. And the muscle fascicle contains many muscle fibers, the actual muscle cells. And then again, the muscle fiber, the muscle cell, contains many internal structures, the myofibrils. So muscle fiber contains many myofibrils, which are specialized intracellular structures. And the myofibrils are the ones that contain thick and thin filaments, also known as the cytoskeleton elements. And so we will concentrate on the myofibrils, the specialized intracellular structures of the muscle fiber.
Right? Those are the contractile.
And we'll specifically look at a portion of the myofibril. And a portion of the myofibril, they all contain the thin filament here in blue and the thick filament here in red. And an important terminology to know is a sarcomere. And a sarcomere runs from one Z line to another Z line. So from basically one thin filament Z line to another thin filament Z line. And so if we zoom into this one sarcomere, here we have the thin filaments made up of actin, and the center of the sarcomere we have what's called the M line. And from the M line, in the center, we have the thick filaments.
He's currently talking about stuff you don't need to know, right? M line,
which are made up
of
protein.
But
remember, sarcomere runs from one Z disc or Z line to another Z disc sarcomere. So here we have one sarcomere line to another Z line here. And a sarcomere is a section and extends from one Z disc to the next Z disc. Okay? And so, and then we have our elastic forms thick filaments, and then
yeah. So it gets a little bit more involved in what's going on in the sarcomere than you may necessarily need to know. But did that help at all watching that video?
Yeah.
A little bit, just to get a better idea of the organization of the muscle. Just watch it again. I'd say if you just watch that one more time, you'll probably have all the information you need to do well on the exam. These are included. Oh no, they won't be, because I upload these as PDFs, huh? See, in my PowerPoint, I have these notes down here where I've populated those. So what I'll do, I'm just going to copy and paste these. And send these to you. It's a bit of an oversight on my behalf. I'll send these all to you this afternoon. Yeah, right, because they wouldn't have come through in the PDFs. Okay. If you just watch those videos that I'm sending to you now, once or twice over the weekend, take 30 minutes, you should be good on all of your muscle cellular anatomy. That's how it worked for me anyway. It just seems like watching videos of guys narrating animations of muscle organization seems to really help. So let's just briefly touch on it again. Remember, the sarcomere is the smallest contractile unit of muscle tissue, right? So it's a piece of muscle tissue that if you were to put that in a petri dish and depolarize it with a charge, it would be able to contract. If you took a piece of a sarcomere, it wouldn't contract, no matter how much charge you put through it. That's what this means by saying the smallest contractile unit of muscle tissue. It's the smallest piece of muscle tissue that is able to contract as a single unit. It spans from Z-line to Z-line, right, which is just these sort of jagged edges of the actin. And it contains actin, which is the thin filament, and myosin, which is the thick red stuff with the oars on it that attach to actin and sort of row to cause a contraction within the muscle tissue. Touched on this a little bit. You want to know this diagram. I'm going to test you on the elements of this diagram. So we're going to go over this we're going to go over this with an online interactive thing. Before we do that, let's just talk about it a little bit more. So remember, you've got, in general organization, you've got muscles, which are made up of bundles of things called fascicles, which are made up of many, many muscle fibers, right, which are made up of myofibrils, which contain actin and myosin, the thick and the thin filament. Right, and the sarcomere is a cross-section of a myofibril, this last bit, running from Z-line to Z-line. Hey, Danny?
Sorry, right.
That's all right, man. I got your message. I just didn't have time to respond. All good. You just missed a narrated, illustrated video of sarcomere anatomy.
Yeah.
I'll send. You're already good on this.
Yeah,
This is
that
stuff
should
you
be
spend a
fine.
lot of time on. For whatever reason, guys, in school, in any of the health sciences, we spend an inordinate amount of time talking about muscle microanatomy. I think having a general concept of how it works is useful, but they spend an incredible amount of time on this. So I'm intimately familiar with this, even though this was years ago. Dani, this is fresh for him, still fairly fresh anyway. Has spent heaps and heaps of time on this already. Have you seen much of this, Sarah?
Kind of,
This sort of
but
stuff, a
not
little bit?
as in depth.
Yeah, and maybe you'll see more later. Anyway, yeah, we're just talking about this organization. Around muscle, you have epimysium, peri, around these guys, and then endo, around these guys, right? This is this kind of fibrous tissue that just works as a sheath around each of those layers of the muscle tissue. There's also something called the sarcolemma, just deep to the endomysium, and there's superficial fascia, which is continuous with the epimysium that surrounds the muscle belly. Remember when we talked about fascia, anterior and posterior slings, that fibrous tissue that kind of helps integrate your entire muscular system. That's continuous with this very fine sheath of, it's like that silver skin on like a roast or something, right? Like that's what we're talking about here. And that connects to the tendon, which connects to the bone, which is continuous again with the periosteum, which is just another type of similar tissue that connects, sheathes bones. And so it's just all one sort of continual flow of the ubiquitousness, if that's a word, like the volume of fibrous tissue that kind of connects all the cells and systems of your body is pretty full on once you start studying it. Like it really is, it speaks to the interconnectedness of all the systems and all the complexes of the body. So again, muscle made up of fascicles, made up of muscle fibers. Muscle fibers contain myofibrils, which are made up of thick and thin filaments, being myosin and actin. Right? You've got epimyosin, which surrounds the muscle, peri that surrounds the fascicles, and then endo that surrounds muscle fibers. That's it. That's what you need to know. Then you just need to be able to remember those, right? It goes epi, peri, endo, in terms of depth. Starts with epi, goes to peri, goes to endo. So, I've got a
So the myofibril is just a chain of sarcomeres, basically.
say that again, the myofibril?
Myofibril is just
Is a chain of sarcomeres. Did everyone hear that? Because that was spot on, what Trev just said. Your myofibril, a sarcomere is just a segment of a myofibril. Yep, exactly. Okay, have a look here. Can everyone see that? Just help me label this.
Bone.
That's the first one.
Alright, Danny, you got the rest, mate.
Jesus. That's loud, isn't it?
All yours, Danny. Take it away, mate.
No, Danny, you're not involved in it. I don't want to hear anything from you. I want to hear from Sarah and Jess.
Tendon is the bottom one.
Yeah. And this is the way, you're probably all already doing this, but let's just touch on it quickly. This is a method of deduction, right? Where you take the things that you're sure of and you place those first. And then the fibrous tissues that we talked about, you probably want to place last. Those are the ones that are most unfamiliar. What else we got there?
Muscle belly.
Yeah, where is it? Up top. Big red one, this one. Yes, okay, nice. What else we got that's easy? We're getting down there, aren't we? Blood vessel's going to be tough because you can't really see all of these real well. I think blood vessel is, it's pointing to a small red dot, you just can't see it. Yeah, okay, cool. Okay, we've got 4 left, guys. We've got those fibrous tissues. We've only got peri and endo. We're missing epi, that's fine. Which one's the muscle fiber? So, start by just working down your organization, right? What's this? What's this?
Muscle.
The muscle, right? What's one of these? Fascicle, yeah, absolutely. Fascicle. Right, goes muscle fiber. They're made up of a bunch of fascicles, which contain what? What do fascicles contain?
Muscle fibers.
Exactly, yeah, fibers. Right, so we've got fascicles containing fibers. Is that one of them? Yeah, fiber. Can you place that for us, Trent? Drag and drop.
Yeah.
Far off. What? No. I don't think so either. Because you were looking at a connective tissue. Quad plugs with the power thing on the plug always catch me out.
Is that running battery as well? Or is it just
Does, yeah. I just never charge it
Right.
outside of lecture, right? Like I charge it while we're in lecture and it gets it just long enough to keep it going for 20 minutes. Where were we? We said this was the muscle. We said this was a fascicle. And what did we say that was? What are fascicles made up of?
Muscle fibers.
Fibers, right? And you can't see it in this diagram, but what are muscle fibers made up of?
Myofibrils.
Myofibrils, right? And segments of a myofibril are called,
Filaments.
like Trev said, sarcomeres. Yeah, which are made up of filaments. Yeah. So filaments are in the myofibril. Yeah. Cool. So where were we? We were saying the muscle fiber was that last one. I wonder what it's asking for. You reckon it's that one? It's that one. So that means we've only got connective tissues left. So if you're looking at this, what's that one going to be? We can identify that as the most superficial, right? Well, it's actually not, is it? Because the outermost is called epi. So we don't even have it.
Trickery.
Absolute trickery. Is that maybe
Very
they're saying no?
I think that big.
That there we go.
One
Okay,
at
so
the
they're
top.
saying that is. So
Is-
now we're left with now we've got our fibrous tissues left. That top one is surrounding a fascicle, I imagine. Okay, so that's saying that's that. And then that is surrounding the
Random pulls me into it.
graphics, huh? Beautiful. There goes the whole thing. That's in the most up-to-date Dropbox slide decks. I've got this diagram in there now instead of that. Yeah, this one's a little more complex. Still use that one, but I'm going to include an image in the exam of this organization system. You need to do that activity that we just did. Yeah, so just keep that in mind. And I've included another image from the same series of images that gets into the further breakdowns. Right, gets into the myofibril and the various proteins involved there. And there's more to this, guys. I mean, like I said, it seems like we're really digging in here. We're not. There's all sorts of other stuff going on. Titin and other proteins. We're just not going to talk about them. Spinal cord. I've just chucked this in here. We're going to talk about this in part 3 of anatomy when we look at the trunk, and that involves the spine, bony anatomy, and so we look at nervous system at the same time. But because I started talking through the flow of information from the brain to the muscle cell, I just wanted to touch on it here. So, the spinal cord, right, that sort of thick pillar of nervous tissue that runs through your spine, through the vertebral foramen, it's called, starts at the base of your brainstem, and then it travels down, like I said, within the vertebral foramen. The posterior side of your spinal cord is dedicated to sensory feedback. So that's bottoms up. And then the front, or the ventral side, is dedicated to top down feedback. So going, well, not feedback at all, right? But yeah, like motor commands essentially. So from the brain to the muscles. In the front, you can see this weird diagram of information. Let me just explain it a little bit. So the bodies of nerves are housed, well then, in the ventral side of the spinal column. You have these bodies. In the dorsal, the bodies are actually housed in the dorsal root ganglion. Information you don't need to know. Just know that the back side of the spinal cord is dedicated to sensory feedback. The front side, or the ventral side, is dedicated to output motor commands. Once you get out beyond the spine, nerves become mixed, and that means that they carry both sensory and motor commands, right? So you've got the bodies are housed in here, and the axon, which are those tendrils that nerves relay information out through, are what we think of as nerves, and they're mixed. They carry both sensory and motor. Does that make sense? So what we're looking at here, right about there, is where this picture is taken. So what I mean by that is the vertebral foramen. It's tough to sort of image here, but think of that as being the vertebral foramen. So that's the hole in a vertebrae that the cord travels through. It goes to about there. So what we're seeing here is that split there, right? Carrying information just to the sort of central part of our back, and then this innervates everything else. We'll talk about this some more later, but I just wanted to touch on this today, just to say that information goes from the brain, goes down the spinal cord, comes out through this ventral part of the spinal cord, or the front of the spinal cord, and then diverges, this going to most of the body. The dorsal rami feeds just the posterior part of your back, just a small part, it's a smaller divergence. Gives you an idea of what that looks like coming from the spinal cord. Then the ends, so there's many ends of this spinal nerve, right? This is now called a spinal nerve. The ends look like this. This is where the nerve gets to the muscle. And again, go to YouTube, watch a video. It'll show like an actual animation of this flow of information. And it's easier to visualize, I think, if you're watching this with a video. We talked about this again, watch a video. I think one of the videos I'm going to send you an email of is actually of this excitation contraction coupling sequence. I'm trying to think of whether you necessarily need to know this in great detail. I don't think so. You do need to know this, just the things, the fatigue factors that lead to sort of a less efficient muscular contraction. ATP, glycogen, increased acidity, neural desensitization. These are things that contribute to muscle fatigue, and why it's important that you know that, and it's to do with recovery times. Right, we said that rest between sets is really important, of course it is, but the reason for that is so that your body has time to flush out those fatigue factors and replenish energy stores in the muscle. Super broad, right? Just know the fatigue factors, know why they're important. And watch a video or two on YouTube. Not going to go over it. The fiber types. Is this pretty intuitive to you guys? You should already know a little bit about this. Aerobic, slow, muscle fiber types. Type 2B, fast. A couple in between. One being adaptive. One being sort of just a fusion. Know these general trends. Generally, type 1 fibers have a greater density of mitochondria, because that's where we process oxygen to produce energy in the cell. And they also have better blood flow, because they need to get that oxygen from the bloodstream. Right? Whereas type 2, these guys, they don't use oxygen, so they don't need a lot of vascularization, a lot of capillarization around those fibers.
Is it true that the type 2Bs can adapt and become more slow twitch, but it can't be reversed? Slow twitch can't adapt to become more fast twitch?
That's these guys. Yeah.
But it can only go from fast twitch adapting to slow twitch. It can't go back the other way, can it?
And it adapts incredibly quickly and is very slow to go back the other way. So these adaptable fibers can become more efficient at processing oxygen, which essentially means that proliferation of mitochondria and more capillaries in that area. They can then become more fast twitch, but they do it, it's much, much tougher for them to reverse that process. That's why when you take a power athlete and you start getting them to develop their aerobic base for whatever their field of play is, that's poison. That's how you slow athletes down. Generally, athletes want to be quick. Some of these things, like we're born with a certain ratio, right? That's why some people are built for sprinting, others are built for slow and long. Other people aren't built particularly well for either. That's kind of the important stuff from that slide. This is an important one. Muscle fibers are depolarized at a specific threshold of charge. The resulting contraction of a given sarcomere is always of the same magnitude. The way our bodies interpret force of a contraction is through rate, how quickly those action potentials are arriving, or frequency, and the number of motor units that are being called on to complete a task. And there are some cases where there's graded potentials, more so in your sensory systems, like your olfactory and things like that. We're not getting into that. Okay, let's get into it. The hip joint, made up of the pelvis and the femur, right? And the pelvis is made up of three major bones: the ilium, the ischium, and the pubis. Matt made a great point. I forget this because I know my bony anatomy well enough now, where I don't need to think about the bones in order to deduce landmarks and figure out where certain muscles attach. But he's absolutely right. You want to make sure you know your bony anatomy before you start thinking about learning the muscles, because you need to know these bony landmarks. The hip flexes, it extends, it adducts, AB ducts and AD ducts. It internally and externally rotates. It's pretty mobile, second only to the shoulder. Here goes those landmarks that you want to know. Right, ASIS. Why do you want to know that?
It's a point of reference for any type of...
Yeah, great point, but no, that's not what I'm talking about right now. What muscle attaches there? No. Yes. Oh, no. No. Yes, sartorius. Sartorius attaches there. Where does the rectus femoris attach? AIIS. Yeah. PSIS haven't gotten there yet, but the rectus spinae originate in that area. That's on the back end of the pelvis, right? We're talking about right here. ASIS, sartorius attaches there. It's that sling-like muscle that goes across like that. AIIS, which is a little bit lower, that's where the rec fem originates from. That's why the rectus femoris is not only an extender of the knee, but also a flexor of the hip, right? Because it crosses the hip joint. It's the only quad muscle that crosses the hip joint. Super important, another thing when you're studying your anatomy, when I ask you about joints that muscles act on, your first checkpoint is, does it cross that joint? Always ask yourself, when you're thinking about what muscles are active during a movement, identify the joint at which the movement's taking place and make sure that muscle crosses it. Because clearly, if it doesn't cross a joint, a muscle can't act on a joint. Right? That seems like When I said that in the first semester, Matt reamed me out, said obviously that's the case. And then he missed consecutive questions in which I asked him, about specific muscles, what actions they achieved, and he gave me actions at joints that muscle didn't cross. Don't make that mistake. Always go through that process. What's the action? What joint is it happening at? And then ask yourself, before you write down a muscle, does that muscle cross that joint? Right? Does it originate and insert either side of a joint? If it doesn't, it can't act on it. Does that make sense?
Yes.
Thank you. It's difficult, isn't it? Ischial tuberosity. Super important one. There's a slide on this. Why is that important? Jess or Sarah? Any takers? Guys, exam Tuesday. I don't want to be the dickhead manager / lecturer, but seriously, get on your study. Ischial tuberosity is where all your hamstrings originate from. Yeah? So your biceps femoris.
At least you got that far in the lecture last week. That's
No,
so,
absolutely,
yeah.
but that's just the nature of it, right?
Yeah.
At this point, that's why I said last week, look at the slide decks before we lecture on them. Because if this is all new information as I'm going over it, we're already in trouble. Because now we've just got 3 days to study for this exam. And I'll be asking you questions like that. You need to know what the ischial tuberosity is, and you need to know what attaches there. Yeah, a good point. We didn't catch it yet, but still, you need to be ahead with these slide decks on anatomy. Biceps femoris, semimembranosus, semitendinosus, and also part of the adductor magnus, all attached there. Pubic symphysis, probably not as important because it's not an attachment site. It's that little sort of disc of tissue that connects your os coxa at the pelvis there. Obturator foramen. Maybe I should take those out. They're not really attachment sites, so they're not something you have to know for the exam. These are probably pretty important though. I wanted to sort of try to address some of the slides in this fashion. What I'd recommend as you're going through this for your review is that you start with the muscles, get an idea there. You want to print these slides out because you want to be able to have this slide side by side with all the muscles as you're going through them. Right, so you can sort of reference back and say, okay, so the rectus femoris comes from the anterior inferior iliac spine. Well, what is that? And you want to go, okay, it's one of these landmarks, and it's right there. Just so you kind of have a visual cue on it too. We talked about the 3 bones that make up the pelvis, didn't we? The top one being the ilium, posterior inferior one being the ischium, and then on the anterior and inferior you have the pubis. All these, there's so much text on this slide. Don't get too carried away with that. This is more just to show that the acetabulum, remember, is that groove in your hip that your femoral head attaches to create the hip joint. This is just to show that it's made up of a little bit of all 3 of those bones of the pelvis. Like I said, these are just cool, really cool things to sort of ponder over and get a feel for, like, okay, so there goes where my glute max comes from, that's where my glute med comes from, that's where my glute min comes from. Talked about why that's important, right? That's part of your POS, the sacrotuberous ligament. Kind of connects the muscles of your back or your trunk to these powerful extenders of the hip, the hamstrings. Here it is, there's a whole slide for it, ischial tuberosity. semimembranosus, tendinosus, adductor. Where's the it's conjoined tendon, that's right. Biceps femoris as well. There's a common tendon with the semitendinosus, kind of interesting. Common origin for those things, right? I'm wondering how useful it is for us to go over these bony landmarks. No, we won't. We'll come back to those. Chucked in some things like this. Braided trochanter being an important landmark because it's an attachment site for a few glutes. Right, or sort of your posterolateral hip musculature. Everything except the glute max pretty much attaches to your braided trochanter. I'll say that again. Almost your entire posterolateral, which is your glute complex along with your deep six, almost all of them attach to your greater trochanter. Your glute max attaches just below there, and that supplies the glute max with greater leverage going into hip extension. We talked about that a little bit on Tuesday. That's the trochanter. That's where your hip flexors go. Iliopsoas, right? Linea aspera, again, hugely important landmark. There's all sorts of stuff that starts on or ends on the linea aspera, which is this ridge of bone that you find on the posterior aspect of your femur. Right, pretty much all of your adductors on your inner thigh insert onto the linea aspera on the medial lip, and then your quads, your lateral and your medial quad muscles also originate partially from the linea aspera. What is that? Little bug floating around. Hip ligaments. How much do we need to know here? I'm constantly weighing up, guys, the importance of learning the content and what you're probably most interested in, which is just what you need to know for the exam. Ligaments, don't get too carried away. It might be useful to keep in mind that the iliofemoral ligament is the strongest ligament in the human body. Otherwise, you've just got these ligaments, they kind of form a sheath around the neck and head of your femur as it sits in the acetabulum.
So are them two like under each other? So the
yeah.
Okay, cool.
So
no wonder the hips so strong.
Ilio goes there, and the pubo there, and the ischio, is that posterior? Yeah, ischio goes there. And it just makes sense, right? Because the ilium's up top, so that's going to be the iliofemoral ligament. The pubis is anterior and inferior, so it's just going to be on the front and below. And then the ischiofemoral is going to be on the back. The beauty of learning ligament structures is their name is almost always just a connection, bringing together of the two bones that they connect.
Yeah, that's why like the bony anatomy is kind of important, because if you know that, then you know.
Exactly,
You
you know
put
your
two and two together kind of thing.
your ligament structures are just known. You just have to spend far less time on them. And you've just got this funny little one, right? Which, like I said, is an intracapsular ligament, sits in the hip joint. Oh man, see, I love neuroanatomy. I just think it's fairly important, but we're just going to skip it. We're just going to skip it. Okay, so this is what I've done in these new slide decks, is I've put the musculature into compartments. It's particularly useful, and also because it's so easy to, with the lower extremity. The lower extremity is generally compartmentalized, both at the hip, the quad, and the leg. And by the way, leg in anatomy terms refers to your leg below the knee. This is called leg or shank for the most part in anatomy textbooks. So posterolateral, right? You guys know this. I hope you know this already. But your glutes are here, right? Glutes are here. Anterior compartment, we're talking about muscles that act on the hip and not the knee, right? So of course, anterior compartment of your leg, you think quads. We're talking about above that. So you've got your hip flexors, and then this funny muscle called the pectineus, which we'll talk about in a second. And the medial compartment, you've just got all your adductors, right, on your inner thigh, and another slightly funny one called your gracilis. Cool, so glutes for the most part, hip flexors for the most part, adductors for the most part on your inner. Posterolateral, this is the one that we talked about on Tuesday, glute max. It's a big muscle, right? So it's got heaps of origins. Sacrum, posterior iliac crest, lumbar fascia, behind the posterior gluteal line of the ilium. Sacrotuberous ligament, I think that's it. Spans down, connects. It's been cut out here, right? So you can see everything underneath, but it would look like that, like covering that entire area. Goes down to your gluteal tuberosity, which is kind of the top, sometimes called the gluteal ridge on some pictures, which just sits directly below the greater trochanter, and also to the IT band, which has some absolutely fascinating implications when a muscle connects to a big fibrous tissue like the IT band, but we'll save that for another day. Yes, I got them all right. It's a hip extender, right? It's primarily a hip extender.
With the punching unit both, or just the main one?
I think for the exam, the important thing is to remember the main one, which I've labelled as hip extension for the glute max. What does the glute med do?
Adduction, sorry.
Abduction, yeah.
And all those other things, right? Which will confuse you if you get too caught up in that, unless you draw yourself out a diagram showing the orientation of the muscle on the bony landmark that it sits on. If I had a whiteboard, I'd love to draw that out. I think it helps with your understanding to see the lines of pull of a muscle on the bones that it acts on. It makes it easier to understand why it can do flexion and extension, and why it can do internal and external rotation. Because it's a little counterintuitive, right? It's to do with where the femur is in order for that muscle to act on it. Yeah, man, I wish I had a whiteboard right now. Okay, anyway. Medius, those things. Minimus, those things. There they all are. Piriformis, we talk about it outside of the context of the deep six, which are those 6 external rotators of the hip, because it's the one that's most often implicated in symptoms of sciatica, which is that inflammation of and around the sciatic nerve, the largest nerve in the human body. It bookends along with the quadratus femoris. It bookends the deep six. It's at the top, quadratus femoris is at the bottom, and they're just these tiny muscles, very local, just right at the hip joint, that work to stabilize the hip joint and externally rotate it. So they're in that posterolateral group. Where do these guys insert?
Trochanter.
Yes, nice. And where do your hip flexors insert? Yes.
Trochanter?
That's a trochanter, yeah. And where does your rectus femoris originate, Dani? AIIS, yeah. It's tough, you know, once you start making an association like that, like if you tell yourself just a couple more times that it originates from the ASIS, that stays with you forever. Like you review it, you're like, nah, it's AIIS, and then you get to an exam and you just do it again. Like it's so tough to break those bad memories. Yep, so it comes from the front of the sacrum, goes to the greater trochanter, externally rotates, has a weak action of abduction as well. Of course, it's innervated by the sciatic nerve. Deep six, don't need to know these, okay? These are just an interesting group of muscles that work to externally rotate the hip. I wanted to create these slide decks as an ongoing tool that you can use in your anatomy learning, because anatomy, like we said, is such an important part of our job. So if you're wondering why I've included a bunch of information that you don't have to know for this course, for these exams, it's because of that. I just want you to have tools that you can use ongoing as your depth of knowledge and your time spent studying anatomy goes on. I can imagine that being kind of frustrating, like which slide should I focus on? Tensor fasciae lata, the TFL. It's a muscle, it's an interesting muscle because it's continuous with the IT band, right, or tract, the iliotibial tract, which, is everyone familiar with the IT band? No? Mm-hmm.
Painful bath.
Yeah. Does everyone foam roll?
Not ITV.
Not ITV, not if you can.
I
Not
get a
if you
ball
can.
in the TFL, but yeah.
Not if you can. Not if you can avoid it.
Nah.
You roll the outside of your leg, Jess. That hurts. That's your IT band. Yeah, it's a broad, fibrous tissue that runs the entire length and most of the width of your leg, and it tends to gather adhesions, often from friction that develops when you do things in valgus. So when your knee collapses, this band frictions back and forth over various things underneath it, and it'll get worked up, develop adhesions. That's when rolling it hurts. Particularly in females, from the Q angle, they tend to be more prone to go into valgus, and also particularly in people that run excessively, which is anyone that runs for more than a couple of K at a time, right? That's what I mean by excessively. They need to be rolling their IT bands.
What's your what's your view on that? I'm interested because there's a lot of particularly in the last 12 months, there's a lot of therapists coming out saying that people spend too much time on rolling the IT band, essentially mashing it up and not putting enough focus on.
It's fascia.
They basically say that you should be focusing more on the TFL, because if that's basically going to be the tensor of the IT. A lot of the tension will originate from that.
What was that, Sarah?
IT band is more fascia, so when you're foam rolling across it, you're getting the muscles under it, not the actual IT band. So to release that,
What's the muscle underneath it?
Would be what thing?
Anyone can jump in. Almost entirely, yeah. Almost entirely that lateral side of your quad is covered by the IT band. Yep, so you're getting some of that under the IT band as well?
Yeah.
I tend to agree with Trem about the TFL and what you do as well, because they attach to it. Them being focusing on them more so than actually rolling the IT band.
Yeah, interesting though, isn't it? Because that would be...
It has its place, the TFL has its place.
Yeah.
And that's also a big thing is the TFL, because at the end of the day that's its purpose, it's international art.
Yeah, so it's an interesting... When someone comes up with a theory like that, that's very intuitive. You think, okay, muscles that attach there are the root cause. I should be spending my time on those. It really pays to go and test it. What I found in being involved in research, like I worked in a research lab at my university in Chicago, right? I found that one of the things that I had to guard against every day was intuition. Because when something's intuitive, you tend to take leaps of rationale. You say, well, that makes sense, right? That's probably the case. Maybe I won't delve into that as much. That just kind of makes sense. And in research, that's not a great idea. And the problem that I have with the idea that the TFL and the glute are the root cause is who's to say that that frictioning effect that doesn't take active input from the glute or the TFL to cause. Those muscles don't have to be contracting for that tissue to be frictioning. You just need to be moving in any way repetitively, and that tissue can get friction. So when you say that to me, if
I had that happen. I had a lot of adhesions, and it was excruciating getting
what I
fixed.
know is I've been rolling people's IT bands for a decade with great results.
I wouldn't say no.
That's what I know.
Do it.
Mm.
I wouldn't say not
It's
to do
more
it.
of a
More of a
it's
focus.
neural thing, like going over the fascia. It'll I need to release that, and it'll slowly, It's more of a like an inhibition kind of.
Definitely. Yeah.
I think it's more focused, not so much on don't. It was more like people were just fixated so much on rolling the shit out of their ITB. So as opposed to I think the general concept was focusing more on that, on the.
No,
on
I
the
hear you.
cause.
I hear you, and
So-
I'm all for multiple lines of reasoning and trying to get to causative effects. It's similar to the way we do the FMS, right? Where we're not looking for causes, we're just analyzing movement and correcting that. And what usually happens is that the dysfunctions correct themselves based on the way that we treat movement. We're not trying to find specific tight and weak muscles and treat those. That's what clinicians do. We just assess movement dysfunction, and then we try to correct that and hope that the specific muscles involved come right. Same thing goes here. Regardless of the causative effects, if we try a modality and it works, then that's good enough for us.
Yep.
And then, we can absolutely have an intelligent conversation about why that's the case. But the main thing is, in my experience, rolling the IT band is super beneficial.
I do. I was just looking for an excuse not to roll it.
Yeah. And I don't understand
There's
why
got to
we
be a
keep,
better way.
it just seems like we need to discuss it ad nauseum just to confuse people. Like if it helps, then do it.
100%.
Right? Like the amount of people I see who have lateral knee pain after running, and I get them foam rolling for 2 to 4 weeks, and their knee pain's gone. That's happened over and over and over again in people that I've worked with. And the athletes I've worked with the most are runners. That's where my most experience is. So I've dealt with IT band syndrome, ITBS a whole lot. Good conversation though. Let's talk about that stuff as it comes up, the sort of the functional kinesiology side of anatomy as well, because otherwise it's pretty dry. Right? Like I'm just kind of running through these muscle slides. Let's definitely have those discussions. Anyway, TFL, connected to the IT band. So you could say, either way, the TFL either inserts onto the IT band, or it inserts at Gerdy's tubercle, which is an apophyses on the lateral aspect of the tibia, which is where the IT band goes. Kind of like with the quad group, you can say they insert into the patella, or I personally prefer to say they insert on the tibial tuberosity via the patella. But either one's fine. You get that with these muscles that have sort of standalone tendinous insertions. Iliac crest, proximal IT band, or Gerdy's tubercle. It does this. Okay, so abduction, flexion, and internal rotation. Yeah. Something else, guys, when we do exams for anatomy, it's a good thing if when I'm watching you guys take your exam, you're doing all sorts of weird movements. That's the easiest way to remember these different movements, right? Like the sartorius, for example, does this. So anytime I get tested on the sartorius, I just do this, and I ask myself what all of those components are.
Sartorius.
Yeah, I also remember it like that. That's how I taught Matt and Giannis how to remember it. They both had pop fans. So. That's it for the Posterior lateral hip. Easy, right? Glutes, adductors, hip flexors. Oh man. Time flies, huh? Glute max. It's got all sorts of origins, right? Posterior iliac crest, sacrum, lumbar fascia, sacrotuberous ligament, goes to the gluteal tuberosity and the IT band. And what does it do? Primarily hip extension, right? And also some external rotation. Glute medius sits in between two ridges on the ilium, the posterior and the anterior ridge, or gluteal lines as they're called. And where does that go? Greater trochanter, right? We said posterolateral muscle groups, besides the glute max, pretty much all go there. So that's medius, minimus, piriformis, and the rest of the deep six. They all go to the greater trochanter. TFL, it's just in that group because it sits kind of between the two groups. I don't know. Might actually be better in the anterior compartment anyway. TFL comes from the front of the iliac crest. From the anterior third of the iliac crest to Gerdy's tubercle or to the IT band. Anterior compartment, psoas. We talked about it yet? Oh, we better get to it.
Very quick question. The curiosity, the TFL, how exactly does that internally rotate hip? I'm confused. It's attached on the lateral aspect.
Yeah. Because it attaches slightly anterior from its origin. I can, again, it's easiest if we were to draw a diagram, but essentially, once it comes out here, it's pulling. What are we talking about? The TFL.
TFL, yeah.
Aren't we? Yeah. Okay, so attaches there. Yeah, good question. I don't know. I can't figure that out either.
Yeah, I've seen that. I thought maybe
What was it?
maybe external rotation, but
Internal
internal
rotation.
rotation is confusing.
Yeah, it's a mystery, isn't it?
Internal. What are we talking? Hold on.
TFL, internal rotation.
Think about it. If it's because it's kind of frontal, so if
The amount of times I've done this.
because if it pulls here,
Yeah, it's
it'll come in.
yeah.
Because the second.
Because
Shut up,
the
man.
insertion.
Come in there and start.
The insertion is further central to the body than the origin, right?
Further central.
Nah, lateral.
Sorry, other way
Lateral.
around.
Yeah.
Is
Because
further
Gerdy's
lateral.
tubercle is
So
right
it's a
beside it.
minor internal rotate.
Yeah.
Yeah, as a
I
sort of
can see that.
secondary.
Yeah. So.
Unless it pulls
Sure,
in the
sure.
same
So
line,
if
it
it's
has to
here,
internally
yeah.
rotate.
And Gerdy's tubercle's out here. If you look
Yeah.
straight, pulling this way
Yeah.
will cause that. See that?
Yeah, it
This-
would. Yeah, it would.
Yeah.
Yeah, it
Yeah.
would. Yeah.
So far as the origin is further.
Origin's
Pro-
medial to the attachment.
Yes.
So,
yeah.
yeah.
So is major.
I remember we had this
What
exact
Danny
discussion.
said. Yeah, that's what I was just saying. Like
Yeah.
always, there's certain muscles who have a weaker. I think the flexion and abduction portion of the TFL are easy to visualize.
Yeah.
Transverse plane movements generally are more difficult to try to visualize.
The great wonders of
But
the
yeah,
world.
the way Danny explained it was excellent.
Spot on, Danny.
So is major. Anytime muscles originate from something on the spine, it starts getting a bit complex, a little bit complicated. The psoas comes from T12 through L5, transverse processes and bodies. Transverse processes and bodies of T12, the last thoracic vertebrae, and all of your lumbar. And it moves anteriorly, comes down, and it attaches to the
AS.
No.
No, it's because I'm
the
pointing at
femur.
you. It's because I'm pointing at you.
You said it before.
You said it before. All hip flexors go to the lesser trochanter. Yeah, yeah. Most of the posterior lateral hip muscles go to the greater. Both of the major hip flexors go to the lesser. Yeah. There goes your psoas minor, which is a shitty little muscle. Don't pay it any mind, okay? Does just about nothing. Doesn't cross the hip. Right. So it's not a hip flexor. Think about that for a second. Psoas minor doesn't cross the hip. That's why we don't even talk about it. I hate that little muscle. This one does though, right? Psoas major, super important muscle. Sucks that it's got a slightly complex origin. Goes to the lesser trochanter. Mainly does these things: hip flexion and external rotation. But it does these things if the distal end is fixed. If the distal end is fixed, what that means is you're essentially flip-flopping origin and insertion. You're saying that the femur is fixed in space, it's not moving.
So that's still open kinetic chain, right? It's just the...
This would generally be closed. No, that's a good point though. This is exactly where that would also flip-flop. So the psoas major, its primary roles are referred to in open chain movements. So during swing phase for the most part. If your foot is fixed in space, well the psoas can't pull the femur up if you're balancing on it on the ground, right?
What's
And so
an exercise example for that?
Yeah.
Oh, so any like closed chain?
Yeah, pretty much.
Okay,
Any time you're on the foot of the side that we're talking about, bilaterally, it's going to cause that. Unilaterally, it's going to cause that. Unilateral, contralateral. I'll fix it. Iliacus, part of the iliopsoas, right? What that means is it does the exact same thing. These two work as a complex, not as a force couple, Danny. Oh, you haven't seen your exam yet.
Yeah, I think that was, I noticed that in the slides, and that's why I think I kept with it.
No, it's right in the slides.
Is it?
Well, I hope it is.
Yeah.
Let's have a look at it then.
Yeah, because I remember saying that, I was like...
Yeah. So a force couple is defined by two muscles create a movement at a joint, but pull in different directions and from different locations. That's what a force couple is. This is just a synergistic couple, right? It's just two muscles that create hip flexion. Iliacus comes from the upper 2/3 of the iliac fossa, which is inside of the ilium, go down to the lesser trochanter. We're going to run out of time, but I'm not going to speed up. So there'll be no exam on Tuesday, and we'll take an extra lecture for anatomy. Everyone got that? I'm going to try to remind JJ. If I don't, can someone else please tell JJ?
Would the exam be then the following?
I'll think about it.
Okay.
Yeah, it'll either be next Friday or the next Tuesday.
Yeah.
We've got too much to
If
cover
it's
here.
that
It's too
next
late.
Tuesday, that's the one I'm not going to
That-
be here for.
Yeah, you're going to miss one anyway.
By the way.
Yeah. Pectineus. Pectineus is an interesting fellow. He's kind of a cross between a hip flexor and a hip adductor. Both in where he sits and also in his actions. So it comes from the superior pubic ramus and goes to the lesser trochanter and does adduction and flexion. And you can see how that would work, right? Just based off the orientation of those fibers. It's going to pull up and it's also going to pull in, right? Because its fibers are oblique. Oh, my God. Pectineus has a really simple insertion, which I just messed up. It's got an insertion named after itself, right? The pectineal line, which sits just below the lesser trochanter. And like I said, flexes and adducts the hip. Medial compartment. This is what the medial compartment of the thigh looks like. And I've included this image standalone just because I think it's useful to see what's going on here. You've essentially got two primary adductors that come from the pubis for the most part and go to the linea aspera. So they're connecting on the back side of the femur and they pull in towards your midline, right? They adduct. Behind them, you've got this triangular muscle that runs the entire length. So see that guy there and that guy there, they both end sort of halfway down the femur. This one runs the entire length and goes to something called the adductor tubercle. Originates up here, also goes the entire length of the linea aspera, and also even attaches up on the ischial tuberosity. And that's called the adductor magnus. And that's super important. That's why, Trev, we get sore adductors when we squat, at least in large part, and why guys like Tom Platz have outrageous adductor hypertrophy. He squats deep a lot, and his adductor magnus responds well to high volume. It's a powerful extender of the hip. So these major adductors, adductor longus and brevis, pretty boring. They mostly just adduct and internally rotate the hip. Adductor magnus, on the other hand, has two different versions. It's a primary adductor, but it's also a very powerful extender of the hip. Right, like it runs from here back around to the ischial tuberosity, and then also down onto the linea aspera and all the way down to the adductor tubercle, and then back up. It's behind those two. Okay, adductor longus. It's kind of your vanilla adductor. Runs again from crest of the pubis, superior ramus, goes about halfway down the linea aspera. Yeah, that's a little bit dubious, approximately 1/3, probably more like middle 1/3, but anyway, just somewhere on the linea aspera. As you can see, the crest of the pubis, so the pubis, so you have the obturator foramen, which is the hole in your pelvis, right? Let's go back to that. I just want to cover this again because I think
Recording.
it's still going.
It's
We
not,
had
it's
to-
a separate video.
Okay.
We can merge them, it's okay.
We can. Here we go. This is your obturator foramen. Down here is your ischium still, and that's referred to as your ischial ramus. This here part is referred to as your superior pubic ramus, and this is your inferior pubic. Right, so all your adductors are coming from this part. So superior pubic ramus, this is called your well, they call it the pubic tubercle, but the tubercle sits on the pubic crest, and that's what that area is. When I was learning these muscles, what I did is I just drew a triangle like that, and I said, okay, what's the order of adductors and various muscles that run down the inferior pubic ramus, and this back end, I wrote all of my hip extenders, like the hamstring group. You guys don't need to know the orders though, you just need to know where they come from. Here we go. Sure why that star's there. Sure there was a good reason for it. Main thing to know, the adductor longus, guess what? It adducts the hip. Adductor magnus, that's that guy, like I said, that sits behind the other guys and works both as a powerful adductor and extender of the hip. That's why you can get sore adductors from squatting in large part. So that comes from the inferior pubic ramus, so that lower part on the bottom of that hole in your pelvis, as well as from the ischial, so it runs that entire length, and from the tuberosity, which is where your hamstring group comes from. And then it runs down the linea aspera, all the way down to this knob back here called the adductor tubercle. And it does heaps of stuff. It does adduction, both. Adduction, both. Hip adduction, both. I don't know what that means. But it adducts the hip and it extends the hip. And it can do these in certain scenarios, but don't worry about those too much. Also, it's innervated by both the posterior nerve, main nerve of the hip, the sciatic nerve, and also the obturator, which takes care of the rest of the adductors. So it really is kind of a connection between adductor and extender. Gracilis, super long, thin, kind of weak muscle. One of the few medial compartment muscles that cross both hip and knee. And obviously that means it acts on both, right? So coming from the inferior pubic ramus down to the pes anserine. Did we cover what that was? I don't think we have yet. That's the problem.
It's a junction.
It is a junction, yeah.
Duck foot, isn't it? No,
Duck foot, yeah. As you can see, it does hip movements like the other medial compartment stuff. It does the adduction. Also does a bit of flexion and internal rotation like a lot of the medial compartment muscles do. But then it also has a weak action on the knee as well as a flexor. There's some color-coded versions of most of those muscles in relation to each other. Are we done at 2?
We are.
Yeah, okay, we'll stop here. So guys, like I said, remember, no exam Tuesday, more lecture. Get prepared. Want to be able to get through this stuff and be able to quiz you as we go. That's the most beneficial way to run these lectures, right? Is if when we're looking at the bony anatomy, I can quiz you on these things. Because otherwise, I'm literally just going through the slides like you could at home.
We do have 2.5 hours on Tuesdays.
Yeah, right. We should.
Plenty of time.
Plenty of time. Yeah, that's right.
You guys are
Yeah. Okay, so I'm going to stop there. We'll talk a little bit about some admin stuff, and then we've also